Hi, my name is Chase Galloway. I am 17 years old, a senior at Christian School, and this is my submission for the 2025 Congressional App Challenge, an app called Indy ParkSafe. Let me start by explaining what my app actually does. Indy ParkSafe is a web application that helps people in Indianapolis find open parking spots more easily. By entering a location, time, temperature, and search radius, the app predicts the probability that nearby parking meters will be free. It also displays those results on a map with color-coded markers showing users exactly where they're most likely to find a space, with green for high availability, yellow for medium, and red for low. The idea came to me one evening when my mom and I were driving downtown for a Pacers game at Gamebridge Fieldhouse. We spent forever circling the same blocks trying to find an open parking meter, and I remember thinking, there has to be a smarter way to do this. That moment gave me the idea to build an app that could use data and machine learning to predict parking availability before you even get there, something that could save time, gas, and frustration for everyone who lives downtown. Once I had the idea, the next step was figuring out how to actually build it. I built the backend of Indy ParkSafe entirely in Python using Fast API to serve the web app. The machine learning model was trained using Pandas, scikit-learn, and Milan, with a random forest regressor trained on parking meter data I found on Kaggle. The model looks at things like the hour of the day of the week, temperature, holiday status, and proximity to downtown, and then predicts the likelihood that each meter will be available. For the front end, I use HTML and CSS to design a simple, easy-to-use layout that works well on both desktop and mobile. And then I use JavaScript along with the leaflet.js library to power the interactive map overlay that displays results visibly in real time. Now that I've explained how it works behind the scenes, let's see in action. Here on the main page, users can enter an address, for example, 125 South Pennsylvania Street, which is the address of Gamebridge Fieldhouse, and then choose a radius, date and time, temperature, and whether or not it's a holiday. After clicking Estimate Availability, the app displays a results page that shows the average free spot probability for the area, a table listing all nearby parking meters with their distances and availability percentages, and an interactive map where each meter is color-coded based on how likely it is to be available. If you hover over a meter, you'll see the meter ID, distance, and exact longitude and latitude. This allows users to plan their parking before they even leave home, saving time, reducing stress, and helping traffic move more smoothly downtown. And that's Indy ParkSafe. This project taught me how data and design can work together to solve everyday problems. Thank you all for watching my demonstration, and to my fellow Hoosiers, I hope my app makes parking in Indy just a little bit easier.